Everyone, thanks for watching our presentation video for Academia Journal Celaya 2021. This work called 5G Downlink Power Quality Evaluation for 3D Environments. First of all, our agenda, we are going to start with a little introduction about mobile communication context. Then we are jumping into network modeling employed in this work for the simulation setup, and finally the results and conclusions obtained. In the past few decades, mobile communications became a key tool for connecting people, machines, and many other devices. Through social media, cellular networks, and many other communication technologies. Also, the imminent deployment of the fifth generation communication networks are pushing the study of other communication schemes, such as IoT and ad hoc networks. These ones used for smart mobility, smart cities, and sensor networks, for example. This is the key point why it is important to ensure the quality of service in these networks. Our work evaluates the probability of successful communications for three standards that are used in the fifth generation context. LPWAN, a standard used for low power wide area networks, Zigbee used for many IoT applications, and finally EEE 802.11, a well-known standard that includes Wi-Fi. Now, the propagation model proposed is a non-deterministic model where we consider slow fading losses and end users placement since we are modeling three-dimensional cells. The model employed is shown in equation number 1. We consider transmitted power, antenna gains for sender and receiver, the distance between the antenna and the end user with a propagation losses exponent mu, and the last part is a factor that corresponds to the slow fading losses. The sender antenna gain is given by the equation number 2, where we consider the angle between the antenna and the end user. Finally, the success of quality communication is obtained with equation number 3, where we use Q function to obtain success probability. The outage probability is the inverse corresponding to the probability obtained with equation number 3. The setup is a discrete event Montecarlo simulation that were run using MATLAB. 3D scenarios where we employ mobile and fixed users were considered as shown in figure number 2, where we have some examples like antennas and routers as fixed users, and other mobile users such as cell phones or drones or laptop. A communication scenario was modeled as hexagonal cells with 120 degrees sectorization as presented in figure number 1. We run different simulations with different number of users, all of them with 1000 events per simulation, and a variation of the cell radius between 100 meters to 2 kilometers. The power transmission and the sensitivity values for each technology is presented in table number 1.
For the results, is shown in the slide a plot of the distance versus the user probability of the received power to be higher than the sensitivity. In blue is represented the mobile users, and the fixed users is represented in red. It is important to observe how the probability is decreasing when the distance is increasing. The radius of the simulation in this plot is 100 meters. In this case, it's the same plot with a distance of 800 meters. It is notorious that the probability is decreasing with the distance until it is equal to 0, which gives us information about the maximum coverage that will ensure the downlink connection. Finally, in this table is presented the outage probability for different quantity of users and several radius for LoRaWAN technology. In this case, for radius larger than 100 meters, the outage will be above the 2%, which implies that the link connection is not optimal. The same information for Zigbee technology. where the outage probability overcounted 2% after 200 meters. Finally, for IEEE, the outage probability overcome the 2% after 300 meters. After this work, we concluded that LoRaWAN, Zigbee, and IEEE will achieve the 2% of outage probability for 100, 200, and 300 meters respectively. To achieve higher distances, will be necessary to increase the transmitted power level. It compromises the battery power consumption. It is recommended for future works to consider other channel effects, such as fast fading and the signal to interference ratio evaluation. These are the used reference for this work. Thank you for your time.